Hi, I'm Phil, and today we're going to build a Mars rover for our STEM club. It's going to be based on the Elecfreaks, the Nisha robot, and we'll do case 11, the line tracking car. So let's just walk through this mind map to see where we're going. So what we need is a robot map, and it will be turned into a Mars map. And in the follow-up versions, we will do some remote control with a robot. And it's for STEM education. So hardware-wise, we're going to base everything on a microbit. And I'm using the bill of materials of the Nisha expansion board, the line tracking center, 2 motors, and RJ11 wires. In the follow-up versions, I'm going to use a Grove gesture sensor as another way of communicating, and this will be part of a remote control. The remote control will also have a Kitronik View LCD screen, and a lot of the hardware will go on software with extensions for MakeCode. So for the basic robot, we'll be using the Planet X and the Nisha extensions. So we'll have a look at what I've done so far with the projects. So I've done the line tracking, and now we're going to look at 3 different versions. So the simplest one is the case down here, the C3. C2 is the middle one, and the more complicated one is number 2. And you can see the 3 of them all over here. And a diagram of the most complicated case is that we have the BitPlayer operating as a remote wireless control, and it sends commands to the Nisha robot. And you can see that we've got 4 connections there. The line following is on top. Then we've got the 7-segment display. We've added 2 more buttons. So not only does microbit have A and B, but we're adding C and D, and they behave in a similar way. And on port 4, we've got the ultrasonic line rangefinder. Okay, so let's have a look at the simplest one first. And on this one, what we've got is just the line tracker with the adapter. We've got the motors, and here is our connection diagram for that. We add the Planet X and the Nisha remote control on our software, and here is the software. We might actually have another look at that. So we'll move across to the Chrome browser. And if you go to the website at Elecfreaks, you can follow this down. There's the picture of what we're trying to build, the connection diagram, and a good description on how to put the Lego parts together. So if we go right down to the software, you can see here's the software. And I had a problem that the one of the motors, the M4 motor, was going in the wrong direction. So doing a bit of work, I've reconfigured this using more variables. And this is my program for the simplest robot control. So if we actually have a look at that in detail, right on startup, I'm initializing all the variables. So the minimum speed is set to 20. And here I'm setting the left and the right in opposite directions. And the case study from Elecfreaks didn't do that. I'm setting up some additional variables that I'll use in future versions. So there'll be an emergency stop, there'll be local control, and when I'm stopped, I will be able to issue the status as a text variable. And forever, if the local command is more than 0, it will go and process those. So one thing I've done is to add much more functions to my make code. So I've got a function for moving forward, moving backwards, turning left, turning right, stopping the robot, and resetting. So to process local commands, if it's 0, we stop the robot, and if it's 2, we do the line tracking. And here's our line tracking function. We look at whether the LEDs, the line sensing sensors, and there are 2 of them here. You can see the different configurations of those. And if they're both on, we will move forward or turn left if there's only one, and turn right if the other one's on. To get the whole thing going, we press button A, and that initializes it. And if we press the logo, we reset it. So we go back to our mind map. We'll have a look at the other cases. So the middle one is a very simple one where we simply use a remote control. And what I'll do is put this back into presentation mode. So we've got presentation walkthrough, and the project we're looking at is this one here, which is the case 2. So there are 2 components here. There's the remote control and there's the car. And for the remote control, just have a look at the pictures. We've got a BitPlayer. So the BitPlayer hosts the microbit, and you can see the buttons here. I'm using them all, and the joystick. There's a joystick on the left, and on the right we've got buttons A, B, C, and D. A and B are repeats of A and B on microbit, but we've got additions of C and D. And we've also got on top here left and right. So I'm using the left for resetting, and the right one is used to get the status. So this configuration, or this remote control, sends commands to our Nisha Rover robot. And so we're issuing commands by radio. What we want to do is develop a rover for Mars, and it allows communications between the rover and Earth. And there's a bit of latency involved here. So NASA has about a 20-minute delay between issuing commands. And this means that the whole control of the rover needs to be rethought to give the rover some autonomy, because you can't wait for NASA to issue every command. And the rover is going to return instructions back. So it's going to show the status, and that's going to be the stop, the sound level, the temperature, and the acceleration will report it back to NASA from the rover. And we're not using an LCD. We're only using the microbit display. And here are some of the commands. We've got group 1, and this version only implements this group. So if we use the joystick, the middle position does nothing, and the other positions issue the commands here 11 to move up, and we're using all of the functions on the BitPlayer. Group 2 is using the Grove gesture sensor, and we're not using that at the moment, but we are using group 3, which is A and B, A plus B, the logo, And if there's a Mars quake or a loud sound, it will issue the command 34 by radio and stop the rover. So this is all of our bill of materials, and we'll have a look at the we'll have a look at the software now for the Mars robot. So this is our car. Our car is quite similar. So in this case, we've only got the line following sensor, and you can see different views of the rover at the moment. Okay, so watch the following videos and you'll see it how it's moving. But before we do that, the communications is sending an array of the stop status, the sound status, temperature, and acceleration. So, and the reason that we're using acceleration, we can find out whether the rover is on an incline, which is the angle is too high, and then we can reverse it. Okay, so watch the videos and you can see the follow-up for that. This is our simplest Mars rover, version 9, and it only has a line following sensor on the front, and it's powered with a microbit. So let's fire it up. And to put it into line following mode, we press button A. So all it does is just a simple line follow. So there's no radio commands with this one. So here we have our second Mars rover, version 8, and it's using a remote control with a simple sensor arrangement. That is, there's only a line following sensor on the robot. So let's put it into demonstration. We'll issue a line following command by pressing button B on the BitPlayer remote control and see if it works. So you can see our Mars rover is following the line. Now it's wandering off actually. So let's stop it, issue. So this is our most complex model. We have a remote control with an LCD, and it shows us the command and currently showing us the status. So it's showing us whether it's stopped, 1 for stop, the temperature, and also the acceleration. So we can tell if the Mars rover is tilted or not. And we can issue that just by pressing the small button on the back here to give us the status. So let's put it into remote control and get the Mars rover to follow the line. Okay, so we just issued the command. And our rover is following the line. And we can issue a stop by pressing button A on our remote. And our rover has stopped. We can also make it go forward. And we'll stop it here. Okay, so bit hard to put it on the table, probably better to put it on the floor. And we use our joystick to go backwards. and stop it. Okay, and that's our version 7 of the Mars rover.